Alright, let's try to prove Heron's formula, which allows us to find the area of a triangle based on its three sides. Alright, so here's the formula. Area A is equal to square root of s times s minus a times s minus b times s minus c, where s is a plus b plus c all over 2. Alright, so let's prove this. Alright, so here's the random triangle with sides A, B, and C. I put B as its base, and I'm going to use H as its height. And this portion of the base is called B1. The rest of it is a B minus B1. So that's the notation I'm going to use. Alright, so applying Pythagorean theorem to this right triangle here, we have h squared equals c squared minus quantity b minus b1 squared, right? I can use the Pythagorean theorem to this right triangle. H squared can be also written as a squared minus b1 squared. By taking this square root of both sides, we have a formula for h. H is square root of a squared minus b1 squared. Unfortunately, B1 is not one of the three sides, so we have to rewrite B1 in terms of A, B, and C. Alright, so I'm going to look at this equation. By multiplying this out, we get this equation. Alright, so since negative B1 squared is on both sides, I'm going to cancel those out. Then I can put negative b squared over to the other side, c squared over to the other side, then divide through by 2b. So that we can isolate that b1. So b1 can be written as a squared plus b squared minus c squared all over 2b. Alright, then we can put this expression back in here so that we have an expression for h in terms of a, b, and c. Alright, so we're going to take the common denominator here for b. So a squared becomes 4a squared times b squared. And then I'm going to pull out the denominator, so we're going to look at like this, right? So it's a square root of 4b squared on the bottom becomes 2b, obviously. And then what's left inside the square root is 4a squared b squared minus quantity a squared plus b squared minus c squared squared. All right, so we got the expression for h. So area is 1/2 base times height. Height we just found, so we put that expression there. Alright, so you can see that there is a common factor here. So I'm going to just cancel those out. Then 1/2 times 1/2 is 1/2 squared, 1 over 2 squared, and a square root. And then you can see that I rewrote 4a squared b squared as 2ab squared. So now we have the difference of squares. So we can factor it out as 2ab plus a squared plus b squared minus c squared, and 2ab minus a squared minus b squared plus c squared by distributing the negative sign. All right. Then we have 1 over 2 squared still on the bottom, but you can see that here we have a squared plus 2ab plus b squared. We can complete the square, so we have a plus b squared minus c squared. Right? Then here we have, if you pull out the negative sign from all three, we still have a squared minus 2ab minus b squared, and c squared just to put it on the front. So you can write it as a c squared minus quantity a minus b squared. All right, again, we have the differences of squared. We can just factor it out even further. So you have 1 over 2 squared, right? First one can be factored out as a plus b plus c and a plus b minus c, right? Second part is c plus a minus b, c minus a plus b, again, distributing a negative sign. All right, so this can be simplified as, all right, so I'm going to put the 1 over 2 squared inside the square root. It becomes 1 over 2 to the 4th power. So I'm going to have 4 2's on the bottom. So I'm going to go ahead and put the 4 2's there. All right, so I'm going to put the first one, a plus b plus c, in the first spot. Next one, a plus b minus c, I'm going to put it in the 4th spot. right? You have A plus A minus B plus C in the third spot. And then we're going to put the negative A plus B plus C in the second spot, right? So it's the same thing, right? All right, then you notice that here, first guide is obviously S, A plus B plus C over 2, so that's S. And then second guy, all right, so if you look at this as, so you have a negative sign on A, right? So we have, if you think of it as A plus B plus C minus 2A, so 2 cancel out, so it's minus A. So you have S minus A. So you have, second one is the same thing as quantity S minus A. Third one is same thing as S minus B. And the last one is same thing as S minus C, which is exactly the formula we're going for, right? So this is the Heron's formula, which goes that area is equal to square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C all over 2. All right, that's it. I hope that this was clear.